Did you know that Smart Irrigation System can save water while keeping plants healthy automatically? Today, we will build an Arduino Smart Irrigation System that monitors soil moisture and water plants only when needed. Welcome to RoboXCraft, crafting imagination into reality. At RoboXCraft, we help students learn robotics, IoT, and automation through hands-on project kits designed for real-world learning. This Arduino Smart Irrigation project automatically monitors soil moisture level and controls a water pump to irrigate plants whenever the soil becomes dry. Using sensors automatically and real-time monitoring, this project demonstrates how modern smart farming system works. This project is ideal for school or college projects, science exhibitions, engineering mini projects, robotics learning, and Arduino beginners. Let's explore everything what's inside this RoboXCraft kit. In the top, we can see the goodies with some stickers, then Arduino cable to transfer data to the Arduino UNO. Here we have the switch, diode with the capacitor. Diode is for the backflow of the current, whereas the capacitor helps to reduce the spike of the pump. We can see the pump here for which inlet the water and outlet the water in the pot to make the soil moisture. And this is the soil moisture sensor. This soil moisture sensors detect the dryness of the soil and send signals to the Arduino UNO, and the Arduino UNO reacts accordingly. And we can see the relay of the 5-volt relay. Actually, this relay is used for the automatic turn on and off the switch or to control the pump. We have also the Arduino UNO. This Arduino UNO is used to get signal from other components and give the output to the components like display. And this display is used for showing the output whatever given by the Arduino UNO. And in this RoboXCraft box, we include the batteries, 18650 batteries with the holder, with some jumpers wire and the breadboard. Now we are showing the demonstration how to make the Arduino Smart Irrigation. First of all, we have taken the Arduino UNO as a microcontroller and we have the breadboard. And as I have explained, Arduino UNO is the microcontroller where all the components are connected. Now let's start with the 5-volt. Connect the 5-volt pin with male-to-male jumper wire and connect it to the positive rail of the breadboard. Here you can see this is the positive, the red one is the positive, and take the another male-to-male wire, jumper wire, and connect it to the negative rail of the breadboard. Now we are going to connect this LCD display to this Arduino UNO. First of all, take male to female jumper wire and connect these pins. Connect this GND pin to the GND of the breadboard or negative rail of the breadboard, and the VCC pin goes into the positive rail of the breadboard. This SDA of the LCD display goes to the A4. And SCL pin goes to the pin A5. After connecting this LCD display, we are going to connect the soil moisture sensor. It detects the dryness of the soil. There is the potentiometer or measure the resistance from here. First of all, we are going to take to female to female wire, there is no need to know the terminal. We can connect this at anywhere. Now we are going to connect like this. After that, we need for female to male wire. We are going to connect this female to male wire with this soil moisture sensor. Here you can see the 4 pins in the soil moisture sensor. This blue one is the VCC pin, so it goes to the 5-volt rail to the breadboard. And this purple one is the negative GND, that's where it goes to the negative rail of the breadboard. We are not going to connect this third one, DO pin, that's why we are going to connect this last AO pin only to the terminal A0. After connecting that, we are going to use this 5-volt DC relay. First of all, in order to connect this DC relay, we need to male jumper wire. We are going to connect this COM and anode wire with the one terminal of the jumper wire. The COM pin goes to the
इस बात किसी को बात बोलना स्टार्ट कर
Now we are going to connect this battery. First of all, we are going to use the battery terminal here. This is the negative sides of the battery, and suppose this is the positive rail of the battery. The connection is like this. The switch is off now. One pin of the positive of the battery. Now we need two jumper wire. The positive of the battery goes to the VIN of the Arduino. Another male-to-male jumper wire. The negative of the battery terminal goes to the GND of the Arduino UNO to power the Arduino UNO. You can see we are using 18650 battery. Now we are going to this COM of the relay to the positive of the battery. we are using an O-pin.
this part display तो ठीक है
Editor cut this part. Now we are going to connect the pump. The positive of the pump should be connected with an O pin. The pump positive can be indicated by the red wire. We can connect like this and put it like this. That means the positive of the pump is connected to the NO pin. Now we are going to give the power to the relay. For that we need female to male jumper wire. Now this is female to male 3 jumper wires. Got this part. Now the VCC will be connected to the positive of the breadboard, positive rail of the breadboard. And the GND of the relay is connected to the negative rail in the breadboard. And the IN of the relay is connected to the D7, the Arduino UNO. The negative of the take one male to male jumper wire. Take one male to male jumper wire and connect that this negative of the pump with the negative of the battery. After this, we need a cut this part. After this, we need one diode. Connect this diode, the white part, with the positive of the battery and the black, totally black one, with the negative of the battery. Cut this part. got this part. Now here put the diode like this in the breadboard and take two male-to-male wires. As you can see, this part of the diode with the white one, connect that with the UNO of the relay. And connect this totally fully black part of the diode with the common GND with the battery. And you can use this capacitor 100 UF 16 volt capacitor with the positive and negative terminal of the motor. Here you can see this is the negative part and this terminal is the positive terminal, and connect like that, likewise. Now I have connected all the components. After assembling all the components, we have to put the code. For that we need this Arduino UNO cable, and we have to connect Arduino UNO cable with the Arduino UNO and this part with the laptop. Now we have successfully uploaded the code. We have done little changes here. We have used the ceramic capacitor with the positive and negative of the pump, and one capacitor is with the positive and negative rail of the breadboard. After that, let's check how it works. First of all, we collect the water in the jar, and this is the immersible pump. We can dip it in the water, and we have to lift this, and we have to put the pipe in the water only. You can use any box here to lift this. And first of all, let the sensor be in the air, okay? And it is started. You can see in the display the moisture raw is 102 and dry pump off. Right now the pump is off. Now pump is on. The dryness is 101 because the sensor is in the air and the pump is on. Suppose if I dip the sensor, automatically you can see the pump is off and the moisture level is 56, 57. Again, if I take out the sensor from out of the water, the pump will start shortly. Now you can see the pump has started. Again, if I dip, it will turn off. Like that, the smart irrigation system works. In order to work the pump properly, we have to dip this sensor in the soil, due to which it measures the dryness of the soil, and